Hi guys, I'm back again, the author of the Interactive Algebra Workbook. Okay, my next topic is long division. And you'd be surprised, but many of us have forgotten how to do long division with just numbers. Let's see how this is done so that we can make it more difficult and move on to long division with polynomials. So I'm going to take this problem 525 and I'm going to set it up for division. I have my dividend and I have my divisor. The question is, what will give you 5, or close to? 1. So 5 times 1 gives me 5. In division, I'm always subtracting. I'm going to subtract the 5 and the 5, and I end up with 0. My next step is to drop down the 2, and then ask myself the same question. How many times can 5 go into 2? It can't at all. Therefore, I multiply by 0. 5 times 0 is 0. Again, we are subtracting. 2 minus 0 is 2. Drop down the next value. 25. 5 goes into 25 5 times. This is my quotient. Make sure that you are familiar with these terms. This is the dividend, and this is the divisor. Question 2. Set it up for long division. 256 divided by 4. This time, 4 cannot go into the first digit. So now I need to move on to 2 digits. 4 goes into 25 6 times. 4 times 6 is 24. Again, we are subtracting. 1, drop down to 6. Now we have 16. 4 goes into 16 4 times. The answer is 64. Let's multiply this and we get 16 and we get 0. Okay, because now we're moving on to something a little bit more difficult in question 3. So I'll make sure to finish this off. 0 represents our remainder. Here again, we have our dividend. Here we have our quotient. The quotient is the answer in division. And here we have our divisor. It's really important, and the reason why I keep repeating these terms is that you know the language of mathematics. It makes it much more difficult if you do not understand these terms. Question 3, set it up again. Divide by 3. 3 cannot go into 2, so then move on to 21. 3 goes into 21 7 times. 7 times 3 is 21. Subtract, you end up with 0. Drop down the 5. 3 goes into 5 1 time. 3 times 1 is 3. Subtract, and we have 2. This time we have a remainder. So we're going to include this in your answer. Again, we have the dividend, the divisor, the remainder, the quotient. But the quotient now includes a remainder and a divisor. So you're going to take that remainder, 2, and you're going to write it over the divisor of 3. So the quotient is 71 2/3. Now that we've done the warm-up, it'll make doing this a lot easier. Question 1. You're going to take your polynomial, your quadratic in this case, and you're going to place it in that division box, like we did with the numbers. And then x minus 5, the divisor, on the left-hand side. Do the same operation. So how many times can x go into x squared? Your goal is to zero it out. X times x is x squared. I'm able to zero that out. I also need to multiply this by the negative 5. I have negative 5x. Again, in division, you are subtracting. Place this in parentheses. I cannot stress that enough because it changes the signs. So we know that this will cancel out. X squared minus x squared is 0. And this negative now distributes over to the negative 5x to make it a positive. Now we have 8x. Next step is to drop down that negative 40. Perform the same action. So what can I multiply x by to give me 8x? 8. So 8 times x is 8x. 8 times negative 5 is negative 40. Subtract, place in parentheses, distribute the negative. That's a 0. That's also a 0. So the quotient is x plus 8. Okay, each of my problems I like to get progressively more difficult, so question 2 is a little bit tougher than question 1. And I'll show you in a moment. We have 8x4. Okay, right here, we go from 4 to 2. That's a problem. It's like the difference between 102 and 12. There needs to be a placeholder there. We put plus 0x cubed. You need to make sure that they go in descending order. So 4, 3, 2, 1, 0. Now I've already added the placeholder. Then I can continue adding the rest because everything else has been satisfied. Place that in my box. And you need to do the same thing with the divisor. 2x plus 1 is already in descending order, 1, 0. Okay, what I'm looking at are the exponents. Okay, same process. 2 times what will give me 8. X times how many x's will give me x4? 4x cubed. Multiply those. We have 8x4 multiply plus x. All right, then we're going to multiply that 2x by a negative 2x squared. We have negative 4x cubed multiply negative 2x squared. Again, subtract parentheses. This cancels out. This becomes a positive 2x squared, so we have negative 2x squared. Then drop down the next term. Multiply, so that's a negative x. And you see here that we're going in descending order up here. So 3, 2, 1, and next should be a constant. So multiply these, negative 2x squared, negative x. And subtract. Cancels, becomes positive, that's 2x. Last term, plus 4. Okay, what can we multiply to give us 2x? Well, just positive 1. So we have 2x plus 1 and subtract. So 3 is our remainder. So in the case of polynomials, you're going to do the exact same thing we did in the warm-up. 4x cubed minus 2x squared minus x plus 1 plus take that remainder and put it over the divisor. Okay, last question. Hopefully you've paused the video and given it a try of your own. Your first step would have been to set this up. 2x squared. Okay, we have 2. We don't have a 1, but we do have a 0 for the constant. So we need a placeholder plus 3. And now we can draw the box and place in the polynomial 10x4. Okay, and I should mention your placeholder should go all the way to the constant. Same process. What can I multiply 2 by to give me 10? Well, that's 5. How many x's do I need? I need 2 of them. Multiply those and I end up with 10x4. They match. Perfect. Multiply all of these by that same term. So plus 0x cubed plus 15x squared. If I hadn't used a placeholder here, then I would be missing something here when I subtract. So you'll notice when you make an error. Okay, 0, we have 4x cubed. Subtract, we have negative 2x squared because now that's a negative 15. Drop down. 2 times what? Plus 2. I need 1x to make 3 of them. 4x cubed plus 0x squared plus 6x. And subtract. And there you have it, guys. That is how you perform long division on polynomials. I hope this was helpful, guys. If you need any more assistance with mathematics, please check out my book. It is on Amazon and Barnes & Noble. Thanks for watching.